O is a fixed point on horizontal plane, so that's my horizontal plane. That's going to be my point O. Particle mass 0.25 kilograms. So 0.25 kilograms. Release from rest at O, moves in straight line time t. So force up until t equals 12. The force is that'll still be positive. So I've got a force acting upon there in that direction. And then when it gets beyond 12, the force 12 squared is 140, so it's still going to be acting in this direction. But when t equals 12, there'll be no resultant force on it. Okay. The only horizontal force on P has managed to do this. The force acts in the direction of P's motion. I'm just showing that really. And P's velocity at time t is v. So when times t, velocity is v. I've got to find a velocity in terms of t. Value for t is greater than or equal to 12, and hence show something else. So first part, I'm doing it up here where t is greater than or equal to 12 up here, and I'm going to do resultant force equals the mass times the acceleration. Resultant force is the only force is this one here, and that is 1 over 2,400 times by t squared minus 144. It's the resultant force, and that equals the mass, which is 0.25 times by the acceleration. And obviously I'm trying to get a formula for v, so I'm going to want to use dv by dt. If I'd had x, I would have had v dv by dx, but I haven't. So I'm going to solve this, times everything through by 4, and that's going to give me 1 over 600 times by t squared minus 144 equals dv by dt. Separate the variables, I'm going to multiply this out as well. So 1 over 600 t squared minus, and that cancels down to 6 over 25 dt equals dv. Let's just multiply through by dt. Put the integral signs in, because actually I've integrated with respect to t. Put a 1 down there. And that's v. And if I integrate this, power has to increase. That'll be t cubed. So that'll be 1 over 1800 t cubed minus 6/25 of t, and then mustn't forget we got plus c, so we need to find c. So when t equals 12, v equals, well, I don't know. So in order to do that, I've now got to apply this one to exactly the same thing. So now I'm going to have to solve this. 2,400 144 minus t squared equals 0.25 dv by dt, and this is going to give me exactly the same thing, but the sign's going to be the other way around. So v equals, will be 6/25 of t minus 1 over 1800 t cubed plus c. I need to find out on c. I'm told that it's stationary when t equals 0. So when t equals 0, v equals 0, and therefore c equals 0. And so I now need to find out when t equals 12, v equals 6/25 times by 12 minus 1800 times by 12 cubed. And so v equals 1.92 when t equals 12. And so therefore I can put this in here. I'll do it in red to show where it comes from, and that's that red bit there, 1.92. And now I can work out what c is. So that bit's here, I'll bring up to here, and so I get 1 over 1800 t cubed minus 6/25 t plus c equals v. And I know what t is. That's going to be 12. So I'm substituting in t equals 12 and v equals 1.92, and that will give me that c equals 3.84. And so therefore I get v equals 1 over 1800 t cubed minus 6/25 t plus 3.84, And we know when t equals 12, v equals 1.92. I want to know when t equals 24. Substitute 24 into this expression here. I get v equals 5.76, which equals 3 times 1.92, which is what I wanted to do. I've shown that it's 3 times greater when it's 24 than when then t equals 12. And finally, the last part I'm going to do in purple, because I can. And I'm going to sketch the graph, velocity time graph, from 0, I'll put 12 in here, and 24. We know the velocity at 24 is 3 times the velocity at 12. So if it goes through that point, it's got to be 3 times as high. 1, 2, 3. It's got to go through that bit. And the whole way through, as t gets bigger and bigger, the force is getting smaller and smaller and smaller until it's 0. So there'll be 0 acceleration there, and then it's going to go up like that. And it does start from 0. That's velocity, that's time, and that's question 4 done.